Have you ever actually stopped to think about how a towering stalk of raw sugarcane transforms into the pure white sugar sitting right there in your kitchen? Or, even better, how that exact same raw material eventually becomes your absolute favorite chocolates, chewy candies, and golden bakery desserts? Well, welcome to today's Explainer. We're going to uncover the completely fascinating, kind of hidden world behind these everyday treats. It's a really incredible story that perfectly blends heavy industrial engineering with some seriously precise microscopic chemistry. Let's get right into it.
So, here's our roadmap for today's Explainer. We're kicking things off with from field to factory. Then we'll look at extracting and purifying sugar, dive into the science of sweets, touch on quality and sustainability, and wrap the whole thing up with Pakistan's sweet future.
Okay, part 1. From field to factory.
You know, when you look at a sugarcane field, you're literally looking at nature's very own sugar factory. The plant is naturally producing sucrose. But here's the catch. The exact moment that sugarcane is cut down, a ticking clock starts. Time is absolutely of the essence here. You see, the quality of the cane begins to change, and that precious sucrose degrades really rapidly after harvesting. Because of this, it has to be loaded up onto trucks and rushed to the processing facility as fast as humanly possible to preserve all that natural sweetness.
Moving right along to part 2, extracting and purifying sugar.
All right, so we're zooming into the sugar mill now. And this is where the heavy engineering really kicks into gear. Let's break down this extraction process. It looks super complex, but it actually breaks down into 4 highly logical steps. Step 1 is crushing and milling. We're talking massive rollers physically crushing the cane to squeeze out the raw juice. Step 2 is clarification, where physical and chemical treatments pull out suspended solids and impurities. Step 3 is evaporation, boiling away the water to concentrate the liquid. And finally, step 4, crystallization. This is where the actual sugar crystals finally form.
Now, you might be wondering, what happens to all the waste? After crushing the sugarcane in step 1, you're left with a huge amount of dry, fibrous material called bagasse. But instead of just throwing it away, engineers brilliantly repurpose this bagasse as a fuel source. They actually burn it to power the sugar mills themselves. It's a fantastic example of a useful co-product, making the whole food processing system incredibly efficient.
So back to our liquid juice. Once it goes through that evaporation stage, so much water gets removed that it turns into this incredibly thick, heavy syrup. In this specific environment, tiny sugar crystals finally start to grow. But they don't just grow out of thin air, right? They form inside a highly concentrated liquid that we call the mother liquor. Controlling the exact temperature and concentration of this mother liquor is absolutely crucial if you want to get high-quality sugar crystals.
Okay, so we have our crystals, but they're completely stuck inside that thick mother liquor. How do we actually get them out? Well, enter the centrifugal machines. These things spin at incredibly high speeds, using pure centrifugal force to basically pull the liquid away, spinning the crystals totally dry. Once they're dried and cooled down, boom, you're left with the simple, pure white sugar you see in your kitchen pantry every single day.
Which brings us to part 3, the science of sweets.
We've made our sugar, now we're pivoting away from heavy extraction and entering the confectionery phase. This is where the food science really takes the wheel. Let's look at a chemical process you probably know and love, caramelization. If you take that pure white sugar and heat it up under very precise conditions, it undergoes these incredibly complex thermal reactions. It melts, bubbles, and transforms right before your eyes into a rich, golden brown liquid that releases amazing new aromas and deep, complex flavors.
Now, you might have heard of browning in food and immediately thought of the Maillard reaction. But here's the crucial distinction. While both caramelization and the Maillard reaction cause browning and develop deep flavors, they are fundamentally different chemical processes. Caramelization is strictly about heating sugar, and it requires absolute, zero room for error temperature control. If it gets even just a little too hot, those sweet, complex flavors turn bitter and excessively dark.
Think about your favorite candies for a second. Compare the sudden shattering snap of a hard candy with the soft, chewy bite of a gummy bear. They both start with the exact same base ingredient, sugar. So why on earth are their textures so radically different from one another? Well, I can tell you for sure it's not an accident.
The secret lies in the exact formulation. By manipulating things like sugar concentration, water content, and temperature, alongside adding specific acids, fats, or hydrocolloids, food scientists can completely alter a candy's fundamental structure. Sometimes their goal is to completely prevent sugar from crystallizing so the candy stays clear and hard. Other times, they want to encourage very controlled crystallization to get that perfectly soft chew.
This structural control is especially true when we look at chocolate. Making great chocolate requires a specific process called tempering. Tempering is all about controlling exactly how cocoa butter crystals form. If you do it right, the chocolate has this beautiful, shiny appearance and a really satisfying snap when you break off a piece. If you don't temper it, the microscopic crystals form incorrectly and your chocolate just becomes dull, grayish, and crumbly. Definitely not what you want.
Next up, Part 4, Quality and Sustainability. When you're producing food on a massive scale, safety and quality can't just be checked at the very end of the line. They have to be built directly into the factory processing chain from day one. Food scientists run rigorous laboratory tests constantly. They're monitoring moisture levels, ensuring exact color and texture consistency, verifying microbiological safety to keep us healthy, and even designing protective packaging to keep oxygen and moisture out.
And you know, this quality control extends directly to the environment, too. Modern sugar and confectionery facilities are actively working to shrink their environmental footprint. We already talked about using bagasse as a renewable energy source to run the factories, but it goes way further than that. They're optimizing water management, exploring alternative, sustainable packaging solutions, and making sure that every single ounce of energy is used as efficiently as possible during the process.
Finally, let's look at Part 5, Pakistan's sweet future.
So how does all this science connect to Pakistan's massive agricultural and food processing ecosystem? Well, Pakistan has a huge sugar sector, which opens up incredible opportunities for food scientists and technologists. The big goal for Pakistan's food sector moving forward isn't just about farming more sugarcane or producing a higher volume of food. It's really about utilizing brilliant scientists in quality assurance, product development, and process optimization to create incredibly safe, highly consistent, and innovative products that can stand up and compete on a global scale.
So I'll leave you with this question. Will you actually taste the science and engineering hidden inside your next sweet treat? Honestly. The next time you stir sugar into your tea or snap a piece of perfectly tempered Pakistani chocolate, take a second to remember the incredible journey it took. From a raw stalk of cane blowing in a sunny field, through massive industrial crushers, deep into the microscopic world of crystallization, right into your hands. Keep learning, keep exploring, and thank you so much for joining me on this explainer.